Hello everybody. So for our second review assignment, we are going to be talking about similarity. So our first question says triangle JGR is similar to triangle MST. Which statement is not always true? So the key to this piece is you can draw two triangles that are similar if you would like, and you can label them how you feel. Now, if I went JGR, then I have to go MST, because remember, order of the letters is important. So which one's not always true? Well, J is congruent to M. Those match up, first letter and first letter, so that is true. G with T, those don't appear to match up, second letter with third letter. R with T, those match up, third with third. And G with S, those match up, second with second. So the only one that does not match up is choice B. So remember, that's all about just matching your order of your letters. In the diagram below of triangle RST, L is a point on RS and M is a point on RT, such that LM and ST are parallel. Basically what that tells us is we are probably going to set up a proportion. If RL is, 2, LS is 6, LM is 4, and ST is x plus 2, what's the length of ST? So we have to remember that when we are using our bases, so since ML and ST are labeled, we can't use that lower part. So the key is we have to get that whole piece here is 8. Now, one of the things that might help is to kind of redraw our triangles. So RLM has 2 and 4, and then our big triangle is RST is x plus 2. And again, it's not 6, it's 8. So we're going to set up a proportion. There's a bunch of different ways you could do it. I'm going to go 2 over 8 equals 4 over x plus 2. So I went bottom over bottom equals right over right. So when you cross multiply, you get 2 parentheses x plus 2 equals 32. I'll distribute 2x plus 4 equals 32 minus 4 on both sides. 2x equals 28. Divide by 2, and you get that x is 14. But be careful, that's an answer choice, but it says once the length of ST, which means we have to do 14 plus 2, which is 16. So the answer to this question is 16. On the set of axes below, AB is dilated by a scale factor of 5 over 2, centered at point P. Which statement is true? PA is congruent to A to A prime. So the only way that would be true is if it's doubled. So if our scale factor was equal to 2, which it's not, because the only way the distance from the center of dilation to the original and then from the original to the new is going to be exactly the same is if that were a mid-segment. In other words, our scale factor was doubled. AB and A prime B prime, well, obviously they didn't stay the same. Choice D is close. That almost makes sense if it was this. So if A prime B prime was equal to 5 over 2 of AB, so remember you'd have to multiply the original by the scale factor to get the new one. And you can probably see visually here from the picture that the only one that makes sense is that those two sides or those two segments remain parallel. In the diagram below of right triangle ABC, altitude CD intersects hypotenuse AB at D. Which equation is true? So this is one of those where it's one of the 3 right triangle questions, and you're going to want to redraw your small, medium, and big triangles so that they are all facing the same direction. So I just redrew all my triangles. There's my little triangle ADC. I kept that one facing the same way. Then my medium triangle was basically a 90-degree rotation to get it to face the same way. And then the big triangle needed a little bit more working, but remember, the B and the B are reflexive, so they should be in the same space, and the A and the A are reflexive, so they should be in the same spot. And now it's just about going answer choice by answer choice. So AD over AC, so bottom over hypotenuse, equals CD over BC. Well, it seems to match up okay, but let's check the others. So if I go across here to choice C, AC over CD, so hypotenuse over right, equals BC over CD, hypotenuse over bottom. Well, that doesn't match. So then I have in the bottom here, I have AD over CD, so bottom over right, equals BD over CD, right over bottom. That doesn't match. And then in the last one, I have AD over AC, so bottom over hypotenuse, equals AC over BD. Well, those aren't even the right triangles. So the only one that works is going to be choice A. And number 5, in the diagram below, BC connects points B and C on congruent sides of an isosceles triangle ADE, such that ABC is isosceles with vertex A. If AB is 10, BD is 5, and DE is 12, what's the length of BC? So this tells us a couple different things that may be important, may not be important. But when I look at this, I look at redrawing my picture here so that I have my little triangle ABC with 10 and X, and then I have my big triangle here of ADE with 15 and 12. And I just look at this, the fact that it's isosceles doesn't help me that much. I really just want to set up a proportion. So 10 over X equals 15 over 12. So I'm going to cross multiply. I get 15X equals 120. I will divide both sides by 15. And I'm going to get that my answer is, and just to make sure I don't screw this up, I'll throw it in the calculator. I get 8. So X equals 8 is my length of BC. After a dilation centered at the origin, the image of CD is C prime D prime. If the coordinates of the endpoints of segment C are 6, -4, and D, 2, -8, C prime then is 9, -6, and D prime is 3, -12. The scale factor of the dilation is, well, remember, our scale factor is always image over original. So we don't have to do it for both because the scale factor should be the same, or is the same, for both pieces. So if I just look at the image of C, if I take my X values, I have the image is 9 and the original is 6, so I get a scale factor of 3 over 2. If I did it for the Y value, I would have -6 over -4, which again gives me a scale factor of 3 over 2. And if I did the same thing for point D, I would end up getting the same exact scale factor of 3 over 2. But the key is this piece that we remember: scale factor is always image over original. So this is one of the tricky ones because we're going to end up setting up our proportion, but we have to recognize that because of the location of our right angles, we have to redraw our pictures a little bit. So it tells us here that AB is 9, BC is 6, DE is 4. What's the length of AE? So if I take a look at what we have here, I need to redraw my picture so that the right angles are in the same spot. I'm going to keep my big triangle facing the exact same way. So that would give me a 6, and that would give me a 9. Then I need to take my small triangle and I basically need to flip it over so that it looks like that. And that's going to give me a 4 and an X. Now my triangles are facing the same direction, and I could create a proportion. So X over 4 equals 9 over 6. 6X equals 36. Divide both sides, and I'm going to get that X is 6. All right, so again, just the key to that question is to make sure that we flip over our triangles so they're facing the same direction. On the set of axes below, triangle ABC has those vertices and DEF has those vertices. Which sequence of transformations will map ABC onto DEF? So if we're going from ABC to DEF, we know it is getting bigger. So our scale factor has to be greater than 1. So just by knowing that piece, we can get rid of B and D because of their scale factors. So we know a scale factor of 2, and then obviously they are not facing the same direction. So just having a dilation is not going to help us. We need to have a dilation scale factor 2 to get bigger, and then we have to rotate it around the origin so that they end up facing the same exact direction on top of each other. Number 9, in the triangle right triangle ABC shown below. Point D is on AB such that point E is on CB such that their two sides are parallel. So again, that parallel really just tells us we're going to set up a proportion. So if AB is 15, BC is 12, and EC is 7, what's the length of BD? So a couple different ways we can do this. Sometimes it helps to fill in any additional information that you need here. So if the whole thing is 12 and we knew the bottom part was 7, then we knew the top part was 5. This could be a helpful one to redraw our pictures. So if we redrew our big one, we'd have a 15 and a 12. And if we redrew our little one, we have an X and we have that 5 that we just found. Now we have matching or corresponding segments. So then we can cross multiply. So 15 over 12 equals X over 5. We cross multiply, we get 12X equals 75. Divide both sides by 12. And obviously we're going to end up with a decimal here, and we end up with a length of 6.25. Okay, so again, before you split your triangle, sometimes it helps to fill in any missing pieces of information. Given the right triangle ABC with the right angle at C and B as 61 degrees, and then given right triangle RST with the right angle at T and measure of angle R at 29. So they're giving you these, what almost appears to be trig questions because you have a right triangle with one missing angle, but they want to know which proportion in relation to triangle ABC and RST is not correct. Now, if you fill in the remaining angles of the triangle, you'll see that that's a 29 and that's a 61. So you'll see that our triangles are similar because all three angles are the same. So what I'm going to do is I'm going to take this small triangle and I'm going to redraw it up here. But I'm going to redraw it to make sure that it's facing the same exact direction. So I keep my right angle in the bottom right-hand corner. I get S to be on top to be my 61 and R to be on the bottom as my 29. So I basically just rotated it 90 degrees. So now they're facing the same direction. So if we look at our proportion, so AB over RS, so big hypotenuse over little hypotenuse, equals RT over AC. So they went big over little equals little over big. So we know that one actually is the one that probably is not correct, but let's check the others. So if we go down to B, we have BC over ST, so big right over small right, equals AB over RS, big hypotenuse over little hypotenuse. So that makes sense. Then if we go BC over ST equals AC over RT, well, that matches up just fine. And then AB over AC equals RS over RT, that matches. So the only proportion that's not going to work is choice A. Now that completes our similarity review, but for our bonus question on the week, that will be the last one on your problem set tomorrow. Your job is to tell me what is your favorite movie of all time and tell me why. Now again, make sure it's school appropriate, but for a bonus question on your problem set, you're going to tell me what is your favorite movie of all time and why, and again, make sure it is school appropriate.